why there is a gap between a well-designed plant room and how a well-designed plant room can also leak some energy. This is my experience of past 20 years that has gone into it. Even by having a best designing in the efficiency, still it could be wasting some of the energy. So I want to run you through the gaps. What can a design and actual performance look like? The first question I would like to ask all of you is why do efficiently designed HVAC plants so often operate inefficiently? It is maybe the designing has been done very correctly. The contractor has installed the approved equipment. There is no gap from the design intent. The PMC has completed the checklist. The operators are maintaining the comfort, but yet the owners, the building owners are still paying the energy bills over a period of time. So what I understand is what I believe is that design efficiency is an intention that we want to have into our building. But operating efficiency is the outcome what we want to have. There's a gap between the two becomes the operating cost, which I believe nobody wants to pay. And where from this an efficiency gap emerges? I believe that at every handover of the project, there is some performance responsibility that gets left behind. It could be from the design to the selection point, from the selection to the installation, from installation to the commissioning, and from commissioning to the operation. Every stakeholder, I believe, is doing their work very correctly. But my question comes in that who remains responsible for this performance of the entire whole plant after it has been commissioned and handed over? So what I feel is the where we can find the leakages every plant room is having is I found in the plant room there are majorly three places where these energy losses are happening. First is the plant room is doing unnecessary work. There is excessive flow from the design. There is excessive head from the design and oversight operations at the part load because in northern part of India, our buildings operate maximum at the part loads, but still because of the controls missing, so they either running in the manual modes or running at the oversized condition. Then the equipment I feel is not running as a system. They are the equipments which are running individually with their individual controls. But the sensors and the control logic do not reflect the actual demand of the building. They are working very good in the isolation, but as a system, somehow they are not able to meet the demand of the building. And the third important part is the measuring of these outcomes. I don't find nobody finding anybody is working on the kilowatt per ton of the plant room. We talk about kilowatt ton of the plant of the chillers, but we are not talking about the kilowatt per ton of the entire plant room, which is working as a system to feed the entire building. The individual equipment is getting monitored, getting rectified, but not as a system. So, if this leakage is happening, who is suffering when this design intent is not delivered at the actual ground level? What I feel is that first of all, the suffer is the owner who pays the excess energy bill. Then there is the facility team who are managing the repeated operational pressures. The same breakdowns are coming again and again for them. Then is the design consultants who are facing questions on the expected outcome. What they have designed is not getting delivered at site after when the peak load comes to the building. Then the contractors who are pulled back for the post handover issue. This neglect never comes to the zero. And then the PMCs also who has to prove that system level closure has been done. And this is what I feel that has been the gap in the design intent and the actual delivery. We have done one of the hospitals where there was a pumping system we were measuring through it. It was taking 16 kilowatt at the part load. And what we found was that it was running 24 into 7, being a hospital. It was working on the full required flow and occupant comfort was there. Though it was a variable pumping system, but it was running on the manual mode. VFD was modulated by the operator, not by any automatic controls. So the pump was running, the cooling was available, but the thing was nobody was measuring how efficiently the system is running. So when we went to the site and we measured it, uh, we didn't went and just change the logic straight away. We measured what is happening at the site, what is the behavior of the system. We compared what is the real demand versus what is the design day assumptions through the equipment, what was it was designed for and how it is operating. Then we removed unnecessary uh, sensors which were not working. Then we verified how this cooling is working, the flow and the comfort after the correction. The saving just did not come through just putting a VFD. It was came when we started making the system respond to the actual demand. And the result was that same 16 kilowatt went down to 6 kilowatt. The same pumps, the comfort was same. We didn't compromise on the comfort, but the same thing was delivered at one third of power, which is almost a 62% reduction in the pumping power, almost 10 kilowatt power save, and 6 to 8 lakh saving for the client. The system consumed very less energy, but no comfort was compromised because unnecessary work was removed from the system. Again, we worked on two more plants. We saw there were different buildings, different application, but the same pattern was there. We verified the same thing in the two more plants. In one of the university campus, we worked out the same phenomena. We checked how the demand is working, how the design was there, and what corrections can be done into the system, which saved around 8.7 lakhs for them. And for one of the campus, there was a call in the commissioning time, the chiller was not getting operational. And it was assumed that the pump was not performing, not able to give them the desired flow, which is required. But when we ran through the datas, the pump was showing the flow and head, which is getting delivered at site. So we were able to get know the pump was running at the higher head from the design intent. We worked out within 2 hours, we found the choking in the pipeline, which helped us to commission the chillers much faster, which normally would have taken us 3 4 days to run through entire piping to check where the blockages could be there or to recheck the design. So that we could avoid because we had got the data on our hand through the VFDs that what flow and head the pump was able to deliver. So what I think that what we can do differently is that every stakeholder can take a small corrective action. I would say the corrective action from their end so that we can avoid such issues after the project is handed over. For me, the consultant start mentioning the performance number a plant two must achieve, not only the COP of the chiller or individual equipment, but as a system for which they have been designing. For the contractors, they should start seeing this as a system, not only as the equipment, but as a system, that how they can start the entire system. For the PMCs, the implemented control sequence has to be there under the operating conditions because in northern India, what I have seen is when we hand over the building, the load is not there for which this entire system is designed. So it takes almost a year or so to get the entire load. So some control should be there to check this performance when the peak load is there, and the owners and the operators to continually measure the performance after the handover has been done. It should not, it is not the intent that nobody should needs to own the blame, but everybody should own one part of the outcome so that we can deliver what is intended during the design stage. I just want my audience to remember one thing that we should stop commissioning the equipment. We should start commissioning the performance. If we are before closing, if we cannot answer, we should have answer of at least one of these three questions. What is the plant's actual kilowatt per ton? Is the control sequence responding to the real demand? Has comfort been maintained at the measured efficiency? So whatever efficiency we have designed, are we able to get the same efficiency without compromising the comfort at any stage of time? The efficient equipment, as already my panelists have already talked about, the equipment has to be designed very efficiently. But I believe that next generation is not only the energy efficient building which will be created, but it has to be operate efficiently throughout its. For me, a plant room is not a collection of equipment; it's a measurable performance asset. And I strongly believe if it is taken as an asset, it is the most profitable asset in any building, which can give you your payback much faster than the any other equipment in your entire HVAC. So one question we need to ask ourselves is what number is our plant room is delivering today? Are we really able to measure what we have designed this thing? Thank you.